Okay, today on the bench, this is HP 5314A universal counter. I'm going to take this apart and look at the capacitors, check out the insides, and see if we need to do anything before powering this up. I'm sure the main capacitor in there will need to be swapped out, but we'll see once we get in there. So stay tuned. Don't forget to like and subscribe, and we'll be back in a moment. Here I have the top off of my HP 5314A universal counter. Let's see if I can get in on that label there. And got this used off eBay. Just wanted to make sure before I fired it up that the main power cap, which is right here, well, that's showing up here. It's a Sprague 4000 UF 15 volts. It was sitting right here on the board. And so I pulled it out to measure it, and it's reading about 6,000 UF. So that's way off. And so I went to go try and order one. And nobody seems to have them. There was one place I've never heard of before. Mauser and DigiKey didn't have any. The other place supposedly had some. Most of the places you have to order 90 at a time. So that's not going to work, especially since they're $15 each. So here is, I grabbed some of my in-stock 1000 UF 16 volt capacitors. And when you put them in parallel, they add up. The voltage stays the same. So I now have 4000 UF at 16 volts, and I just plugged it into a breadboard, put a couple test probes into there, and then powered her up on the variac and dim bulb tester right up here. And everything appears to be working. So my next plan is, because it looks pretty sloppy when you do things in parallel, I'm going to go to my Easy EDA program and make a little circuit board that all four of these can sit right next to each other and get silicone together, and then I will pop leads down into the board where the original blue one went, because they are about the same height or lower. And I'll just make the board so it's the right width so that it fits right in, and maybe a couple spots of hot glue under it, just to keep it separate from the main PCB, easily removable. And everything tested out good that way. I may try to, I think when I measured these four, they came up at about 4,500 UF, or 4,500 UF instead of 4,000. So I might pick through, I have a bunch of those, and line them up so I get closer to 4,000, because this is a counter, and I don't know how much effect the actual UF. Usually you can go high and it's better. Same thing with voltage, but not too high. But I am not sure on a digital counter how much that will affect. I don't know enough about this unit. I'm still working on learning how to run the unit. And I need it because I'm still working on the radio here, this realistic, and I want to do the frequency, check the frequencies, and tune all of these. There's quite a few I think there, what do I see? 1, 2, 3, 4, 5, 6, 7, 8, 9, at least 9 frequency IFs in there. And I can use this then to make sure I'm getting the right frequencies. The other thing I got to look into, it did seem to work fine, but these two little fuses here are very strange. They're a 1/16 amp fuse, 250 volt. I've never seen anything with these like wound around cotton. I know I'm not getting, let me see if I turn this one light off, if we get a better, yeah, doesn't seem to matter too much. But so I did pop them out, and one read 230 ohms and the other one only read 81 ohms, but they're identical fuses. So I got to look up the specs on those and possibly get 2 new ones of those. But I was really close on, I used my, I have a little GPS DO, 10 megahertz, and had it coming out of the back there and going into the A channel here. And it was just a little bit over. So I think I'm getting close. But I'm going to go make that circuit board now. And we'll be back when we get that made up, etched, everything soldered together and fitted in there. I'll show you that. And meantime, I'll be trying to find those fuses. So see you shortly. Okay, here's that circuit board I was talking about that I made. That's the silkscreen part. This one's just super simple because then it's just two strips of copper, one for the positive, one for the negative. But that'll make it look a lot neater. I'll be right back in a minute after I solder in these capacitors, and we'll show you what it looks like on the board. Okay, here we're back with the little PCB I made, and with caps installed on it and installed back into the original position of, let's see, there's the original one that was in there. But those are super expensive, and you need to order 90 at a time, so they're impossible to pretty much get. But I did manage to match up the UF ratings, and I got it right at 4,000 UF. I think it was 4,020 UF. And it's 16 volts instead of 15, but that shouldn't matter. I mean, I did test it out before I went ahead and did it, but that's the final mount. It is raised off the circuit board about 1/8 of an inch, and it is glued in place. I did some hot glue to keep it from moving around, so I'm gonna put this back together now and show you firing it up. Be back in a little bit. Okay, back with it all put together. I've had it running for a couple hours now, hooked up to my GPS DO sitting up here on top. That puts out 10 gigahertz. It's picking up 10 satellites right now, using their clocks to set the frequency. And it seems to be pretty spot on. That's 10,000 kilohertz, which is the same as the 10 megahertz. I know there's a way to get a finer reading on this HP counter, but I'm learning that as I go now, but everything is up and running. Very happy with that. And that'll do it for this video. If you found this interesting, please like and subscribe. I appreciate everybody watching. Thank you.